We're gonna work on exponents today, and we're gonna write and simplify. Actually, I have a confession to make. Just gonna continue lesson one again today, and that will be simplifying and writing exponential expressions. All right, so our goal today is to simplify numerical expressions by creating equivalency through exponential expressions. But we usually have something to like share, think about. So, thought for the day. What would you do if you broke mom's favorite dish? Let's see what we can do. I'll give you a
What if
minute.
we don't have a favorite dish? Because we
Okay.
don't really have to.
Something
Mom
that
doesn't, so
what
good
if
luck.
what if you just broke something that is your
It
mom's?
depends what that something is.
Then think of something very special for her. All right? So let's give you a minute to do that. What would you do, Alana, since we're talking? You'll go first. What would you do?
Worry about what punishment I'm going to see mostly. And she's going to find out eventually, probably just say, instead of waiting and then have a bigger punishment, maybe find the right time to say it.
You're really thinking your mom gonna punish you for just breaking it? You don't intentionally break it.
If it's a dish, no. If it's what her most prized
Something.
possession,
Yes,
like if you're thinking her favorite thing, if I broke her favorite thing, she would be furious.
That's true. But just like instinct, of course, those are specials. Selena, but I like it when you say you want to tell. I'm that's what I'm looking for.
All I would do is just buy her a new one with my money. Easy.
Are you not gonna tell her
But
that
then
you
she
did?
can tell. She's the one who cares.
What if this is Selena?
Here in the first place.
Selena, what if this is a thing that was done in 1960s? You cannot
Or
buy
it's a
this
one of a
in store.
1960s? I wasn't even born in.
That's what I was trying to say. What if the thing that was broken was in the ancient time? So how could you buy that in store?
Like an antique store. Go to the antique store and then I bargained for the price.
Oh my
I don't know, search up
Lord.
eBay.
They
got weird stuff
They always
there.
have some. Yeah. I bargained for the price.
You guys are
What
funny.
if the price out of your reach? What if you can't pay?
But then she'll think it's the real one.
Correct.
But then she's the one who pays. It's not like you're gonna let a kid pay with some cash on the internet. Your mom has to approve the payment. So if you don't, she knows.
Well, I have my own money, and second of all, I'm not buying it off the internet because internet scams you.
Yeah, well, if you go to a real store, your parents are gonna see that you buy and get a deal.
All right, guys.
So
There is
Selena.
All right, Selena. There is an easy way to fix this problem of buying. There's an easy way. I'll tell you in a minute. Ayman, what will you do?
Or you can just tell them and say sorry, and they'll be like, "Oh, fine."
That is
They won't be fine if you broke their favorite thing. They'll be super duper mad.
So what? It's just a dish.
At least you told the truth. That's all that matters.
See?
Yeah,
That's what I was looking for. You guys.
It's not like they're going to cry over a dish.
Alright,
if it was a dish from something else, they'd be furious. Like their real favorite thing, they'd probably be furious.
At least it's not like grandma's like veil with her ashes. Well,
on expressions today. So let's go to our next slide. So here we go. So fold a sheet of paper in half. The number of sections you see when it's unfolded is recorded in this table. So continue folding the paper in half. Just imagine that you're folding it. You could fold it in your own if you see. And then record the number of sections that you have. And then describe any pattern you see in the table. We just complete the table and let's see if we were able to figure out how many what happened to the patterns. What happened to the table. Alright, just write on it and then we'll talk about it. Let's see what we have, guys, in this one. But while I'm searching for it, can someone explain? Aiden, would you like to share what you've got in this one?
Which section?
Yeah, go ahead. Like everything, if you want to speak about it. So this looks okay.
That's not my paper.
I know. This. Oh, you had this one. You need to like finalize how much will they be, like 2 times 6 4. So how much will that be? All right, let's look at. Tell me where your paper is. This one. This one is nice too. Look. So there is a pattern. What pattern? What pattern can you see in this problem that we have? Aiden, can you just talk about patterns?
I can see that there's more twos adding on and adding on.
So okay, who could want to add on, Alana?
As you increase the exponent, the number of sections is doubled, because in the beginning when there's only 1 2, there's 2, then 2 2s is 4, then 3 2s is 8, and then etc. It'll keep going on, and it'll keep doubling and doubling.
That's true, and it's almost the same from everyone. So it's just gonna like the pattern. So you add, and if you see 8, 16, 32, the number of folds go up, and it becomes 8. You said you double it, it becomes 16. You double it, it becomes 32. So if I gonna have fold number 6, what do you think will be the number of sections? Go ahead.
64.
Okay, we just, if you see the pattern, you know what's next. All right. Working on lesson 3.1, exercise 1, understand and represent exponents. So how can we write the number using exponents? So let's see how Savas work on this one. So let's see how they explain to us exponents.
How can you write a number using exponents? The expression 2 times 2 times 2 represents the number of cells after 1 hour if there is 1 cell at the start. How can you write this expression using exponents? How many cells will there be after 1 hour?
An exponent is a way to write a repeated multiplication expression.
You can use an exponent to write repeated multiplication of a number. Exponents are useful because they can shorten expressions that show repeated multiplication. The number that is repeatedly multiplied is the base. The exponent tells how many times the base is used as a factor.
All right, I did not pick your hand, Alana, because I know we already learned this in elementary school, but just a recall, 2 is our base, and number 3, the little thing at the top, we call it exponent, and sometimes we call it power. And then 2 times 2 times 2 are the factors, all right, or expanded form in a multiplication form, all right? So let's just listen. It's just a review.
A number that can be written using exponents is called a power. You can use repeated multiplication to evaluate or find the value of a power. Multiply the first 2 factors. 2 times 2 equals 4. Then multiply that product by the last factor. 4 times 2 equals 8. 2 to the third power equals 2 times 2 times 2 equals 8. There will.
So I stop it for a second. So we call this expanded form in multiplication. There's also expanded form in addition. But for the exponents, exponential expression, we expand it using factors, okay?
Be 8 cells after 1 hour. Now you know how to write a number using exponents.
So that is just for writing exponents. So example number 2, I have a feeling that I really have to like tell you first the first power rule. So before, this is what I was trying to show you, but I don't have time to really like type it in. So power rule, let's take the first power rule. So the first power rule is x. Let's say the base is x, the exponent is m, and I gotta multiply it since it's a product. Actually, we could say product law of what do you call that, of exponent, say product, so you multiply. So that's x to the power of n. It says that if the base are the same, we copy the base and then we add the exponent, so they're going to be m plus n. So if we're going to get an example to represent this idea, so let's say I have a 5 to the power of 3, and then I multiply that to 5 to the power of 4. So it means I could write this in exponential form as 5 to the power of 3 plus 4 equals 5 to the power of 7. I don't need to simplify it unless I tell you find the value of 5 to the power of 7. So 5 to the power of 7 is enough just to represent it in exponential form. Let's say give another example. Let's say I have a to the power of 3 times a to the power of 8. So since the base are the same, only if the base are the same, you could add the exponent. If the base are not the same, you cannot do anything about it, but keep it the same. So if that becomes 8 to the power of 11. Speaking of the base are not the same, so say for example, I have x to the power of 3 times y to the power of 2. The base are not the same, the exponent is not the same, so your final answer is exactly the same. So you're gonna have x cubed y squared. So we're gonna deal of this kind in a different time. Question. So if you could take a picture of this, because this is not in a peer deck, I did not write it, you could take a screenshot. Based on exercise number 2, I have to tell you something about the quotient law of exponents. All right, so the division law. So let's say for example the base are the same, and then this time we divide. So that's x to the power m times x to the power of n.
Wait, are we dividing that?
Yeah, now this is division. I'm just teaching you 2 out of 8 law, because in the next video that we're going to look at Savas, we needed to understand something. So this is x m minus n. So it tells us that when we divide, we're gonna subtract the exponent only and only if the base are the same. So let's say for example I have x to the power of 8 divide by x to the power of 3. So we just gonna subtract the exponent and we copy the base. So x will be 8 minus 3, which will give us x to the power of 5. So why did it happen? So we know that I could write this as x to the power of 8 over x to the power of 3, right? We could do that.
Wait, is it because the two x's cancel out and then you just...
That is true. So if you look over here, this is x. This is an expanded form, right? So x, I'm gonna do it 8 times. So that's 1, 2, 3, 4, 5, 6, 7, 8. And it's multiplied. In the bottom, we got x times x 3 times, correct? It just to explain what happened to the exponent, why it becomes subtraction. So if I gonna cancel this, why am I canceling this? What is the meaning that we cancel that?
Because the bases are the same.
Wait, one at a time, Alana.
Because they both have the same base.
What if it is the same base, Selena? What does it mean? What does it mean when I cancel this?
Base, they cancel out each other, so then you have to subtract the exponents because they're different.
Why are we canceling it out? What's the reason of canceling out? Just speak, Alana.
Because since the base would be the factor that the exponent, like the factor that is multiplied by the number of the exponent, then since they both have the same factor, you don't need to multiply.
That's a good idea, but there is a reason behind of cancellation of numerator and denominator.
Because whatever you do to the top, you have to do to the bottom.
That's a good idea too. But anybody else got a different idea why we cancel some some number to the numerator and denominator? You guys don't know? I'll show you and then tell me, okay? So here, that's why we have 1, 2, 3, 4, 5. What remains is x to the power of 5. I'm gonna make this as a number, and then you're gonna answer the question I asked you a while ago. So I'm gonna clear this. I just gonna use an eraser. So
Wait, can I take a screenshot?
oh yes, go ahead. Sorry for that. Go take a screenshot. All right, done. So let me just erase this part. I'm just gonna add some. I'm gonna go for the next example. I could have just.
Laura, I have a question. In this unit, are we gonna have like two different bases, like x divided by y or x times y?
Yep.
Oh.
Oh boy, we're getting there. We're getting to be harder, but it's okay. So I'm gonna put this in a context of a real number, like the number that the tangible number. So if I have 5 to the power of 3, and then divide it by 5 to the power of 2, right? So based on the rule above here, it says I could just subtract the exponent 5 to the power of 3 minus power of 2.
It'll be 5 to the power of 1.
That would be 5 to the power of 1. How did that happen? So if I'm going to simplify this 5 as expanded form or factor form, 5 times 5 times 5, I'm going to divide it with 5 times 5 in the bottom. And remember I told you before that we could cancel out? And I could cancel 5 and 5 and 5 and 5. That's why what remains is 5 to the power of 1. That's 1 5. So I'm going to go back to the question I asked you before. What is the reason of canceling the numerator and denominator? Why did I cancel 5 and 5? Aiden? Omar? Or anybody else? Try it again, Lana.
Is it because since in expanded form they share, like, the top 5, they have more than 2 of the bottom, they have more, higher number than the bottom 2, so they can't select those, and then what's left is the answer?
Close but not close. Lena want to share. Lena? Lena? Are you want to share? Lena, go ahead. Is there anybody else does it know why are we canceling 5 and 5? I know we have 3 minutes left. Go ahead, Lena. Go ahead. You said me? You have a question. All right. So, listen, if you look over 5 over 5, that is equivalent to 1. You didn't even guys think that 5 over 5, 5 divided by 5 is 1, and 5 divided by 5 is 1.
Oh, Lena said she doesn't have a question.
So, but I don't know why she put me. I thought she said me. So that is 5 divided by 5 is 1. And then this is 1. And that's 1. That we simplify that. So 1 times 1 is 5. And then 1 times 1 is 1. That's why we have 5 over 5 to the power of 1. Alright?
Okay.
I'm gonna continue this video. Alright? Let me stop for a second. So the next one that I want to share with you is the law of exponent. Also the same thing with division, but the question that how come x to the power of 0 is equivalent to 1 and not 0. So we have x to the power of m, x to the power of n, and we know that this is x m minus n. So if I have something like x to the power of 5 divide by x to the power of 5, and based on the rule or the law, it's x 5 minus 5, we get x to the power of 0. But how come that this is equivalent to 1 and not to 0? Let's put this example in a number context. So let's say I have 5 to the power of 2. Divide by 5 to the power of 2, right? So I know we could rewrite this as 5 to the power of 2 over 5 to the power of 2. And I know that we could simplify 5 to the power of 2 over 25 divided by 25. And we also know that 25 divided by 25 is equivalent to 1. That's why any number raised to 0 is equivalent to 1 and not 0. Because that's simplify x to the power of 5 divided by x to the power of 5 is like things, this thing is divided by the same thing, so it's equivalent to 1. All right, so that is the power of exponents. So that's up to that point we're learning for these exponents, and then we're going to learn more about this in the next lesson. With that, you're going to be working on your activity or the task lesson 3.1 about expressions and equations. Just expressions in Savas. So go ahead and work. Got question? Just let me know.